Okay, lesson 4 of our algebra unit is representing linear relations. So we're getting into the important part of the course. We're done with the practice algebra and we will start with linear. You did this in grade 9, so hopefully some of this will come back to you. We're going to start with a minds on of just remembering how to graph coordinates on the Cartesian plane. So we need to remember, just like the alphabet, x goes before y in all coordinates. So this first one, we want to count over to 3 on the x and then up to 4 on the y, and that is 3, 4. Okay, then we have left 5, so to negative 5 on the x, up to 2, over to negative 6 on the x, and down to negative 4 on the y. Positive 1 on the x, negative 6 on the y. Okay, 0, 5 doesn't move over at all. That means it is a y-intercept. It just moves up 5. And negative 4, 0 moves to negative 4 on the x, but does not move up or down. So that is an x-intercept. Okay, 4 ways to represent a linear relationship. We can do this on a graph. And on a graph, we will have a straight line. We can do it in a table of values. And in the table of values, we will have identical first differences. We can represent it in an equation. And that will be in the form of y equals mx plus b. And we can do it in words. So that's just a word problem. Example, every y value is 2 less than each x value. Represent this relationship in 4 different ways. So if we start at 0, just count 0 to 4. So the y value is 2 less than the x value. So we're just subtracting 2. Subtract 2. 0 minus 2 is negative 2. 1 minus 2 is negative 1. 3 minus 2 is 1. And there we go. So now when we graph this, so when x is 0, y is negative 2. When x is 1, y is negative 1. And so on. We just follow the table of values and we get this straight line. Okay, in an equation, remember we have a slope represented by m. So m is your slope. That is how is the line moving. B is the y-intercept. The y-intercept on a graph is where does the line meet the y-axis. On a table, the y-intercept occurs when the x value is 0. Okay, to find the slope on a table, we're going to look at the y values and see how much each of them are going up by. They're all going up by 1. That means their first differences are 1. So therefore, our slope is 1. And then when x is 0, the y is negative 2. So the b will be -2. And there is the equation, y equals x minus 2. Okay, and then the words, it just could be any word problem that has to do with starting at -2 and gaining 1. So, for example, after the first period, the hockey team is down by 2 goals, but every period after that, they score another goal. They score a goal. So they're starting at -2 and they're gaining 1 per period. Okay, lesson 4, practice representing linear relations. So we're going to agree or disagree with these points. So this is saying point A has coordinates 3, -2. So point A, we move over to 3 on the x and down to -2 on the y. That is correct, so we're going to agree with that. Point B has coordinates 3, 4. So if we moved over to 3 and up to 4, that would be here. That is not where B is, so we will disagree. Point C is -1 and 1. It is, so we will agree. Point A is in quadrant 4. So the quadrants are labeled 1, 2, 3, 4. Point A is in quadrant 4, so we will agree with that. And last, the origin is located at 0, 0. That is right here. Yes, that is what we call the origin, so we will agree with that. Okay, on to the second one. The rate of change is the slope, but in words, it's comparing units, is $25 per week. So if we take a look at the graph, you can see that it starts at 200. After 2 weeks, it's at 150. That means it is going down $50 for 2 weeks or $25 per week. However, the question is saying the rate of change is positive $25 per week. So we are going to disagree with this. Why the rate of change is negative per week. The initial value is 200, so we can see here that on the y-axis, the line crosses at 200, so we will agree with that. Okay, next one, Chinese food restaurant has a special price for groups. Dinner for 2 costs $24 plus $11 for each additional person. The rate of change is $11. Yes, because of this for each, anytime you see for each or per, that means that the slope will be the number that's associated with that. So $24 just to walk in the door, and every person that walks in the door after that will be an additional $11. So the rate of change is $11. The initial value is 11. No, the initial value is the 24 because even if 0 people show up, it will still cost $24. And the dependent variable is the number of people. So if we were to draw a graph for this, the independent people would be the x, the dependent people would be the y, or values, sorry, would be the y. And in this case, the y is the money, the x is the people that walk through the door, So no, it is the independent variable that is the number of people. So this will be a disagree. Okay, last one. The initial value is 940. So again, initial value happens when X is 0. That's not listed on this chart. It's $9.40 for a one topping pizza. So we will disagree. The rate of change is 110. So again, the rate of change, we're going to find the first differences, and each of these are going up by $1.10. Sorry, each of these are going up by $2.10. So that is false. The rate of change is 210. And finally, the dependent variable is the number of toppings. Again, no. The independent is the number of toppings. The dependent is the cost. Thank you.